We've all kind of been trained to think of AI as this single, all knowing brain, right? But what if the real future, the way we solve really complex problems, isn't with one genius AI, but with a whole team of them all working together? That's the powerful, game changing shift we're going to dive into today. So here's where we're headed. We're going to start with a request that sounds totally simple, but can actually break a super powerful AI. Then we'll get into the solution, this idea of a team of AI agents. We'll see how they actually work together, the new problems this creates, because it always does, how we keep humans in the driver's seat, and finally, what this all means for the AI products we'll be using in the near future. All right, let's kick things off with a challenge. You'd think asking an AI to plan a vacation would be a piece of cake, but we're about to see how a request that seems totally reasonable with just a couple of real-world details can push even the most advanced AI right to its limits. Now, to you and me, this sounds like a perfectly normal request. But for a single AI, this is a Herculean task. I mean, think about it. It has to be a travel agent, a food critic, a budget analyst, and a medical safety expert all at the same time. Forcing one model to wear all those hats is just a recipe for a confused, jumbled, and pretty useless answer. So what's really going on under the hood here? Why does a single, incredibly powerful AI model, one that can write amazing poetry and debug code, totally stumble when you give it a multi-part, real-world problem like this one? Well, this table really breaks down the why perfectly. A single AI just gets overwhelmed. You have context saturation, which basically means by the time it's looking at hotels, it has literally forgotten about the peanut allergy you mentioned at the start. It also has cognitive overload. It tries to be an expert at everything, but ends up being mediocre at all of it. And this last one is a killer, error compounding. One little mistake early on, like miscalculating the budget, can snowball into a completely disastrous and useless plan. Okay, so if one generalist AI can't handle it, what's the fix? Well, we build a team. This is what's called the multi-agent approach. And if you're in tech, this will sound familiar. It's a lot like the microservices revolution that completely changed how we build software. And this analogy just hits the nail on the head. Asking one AI to plan that whole trip is like asking one person to launch an entire software product. I mean, maybe they could, but it wouldn't be pretty. The multi-agent system is like a real team. You've got a specialist for flights, another for hotels, and a project manager making sure it all comes together. Specialization, it turns out, just works better. So who's the project manager in this AI team? It's this incredibly important piece called the orchestrator agent. You can think of it as the brain of the operation. It looks at your big, messy request, breaks it down into neat, smaller tasks, and then, and this is key, it delegates each task to the right specialist. It's the conductor of the whole symphony. All right, so having a team of specialists sounds great, but that brings up a brand new problem: coordination. How do you get all these different AIs to work together smoothly without stepping on each other's toes and creating total chaos? Let's check out the playbooks. The simplest way to organize them is in a pipeline. It's basically an assembly line. So if you were building an AI to write blog posts, it might look like this. The researcher agent finds the facts, then it hands them off to the writer agent, who then passes a draft to the reviewer. It's simple, it's organized, it's easy to fix if something breaks. The downside? It can be slow because each agent has to wait for the one before it to finish. Now, for our Japan trip problem, that assembly line is just way too slow. A much better approach is to have the agents work in parallel. I mean, the flight agent doesn't need to wait for the hotel agent, right? They can all do their jobs at the same time. The flight agent finds flights, the accommodation agent looks for hotels, the activity agent researches fun stuff to do, all at once. Then the orchestrator pulls all their findings together at the end. It's way, way more efficient for these kinds of tasks. But of course, as the saying goes, with great power comes, well, great complexity. This powerful new approach isn't a silver bullet. It actually creates a whole new set of challenges, especially around cost, complexity, and what happens when things go wrong. Take a look at this, about 8 cents for one request. That might not sound like a lot, but what if your app gets 1,000,000 requests a month? All of a sudden, you're looking at a bill for over $80,000. When you're operating at scale, cost isn't just a detail, it's a major engineering problem you have to solve. Luckily, there are some really smart ways to tackle this. You can use model tiering, which means you use the big, expensive, powerful AI for the super important orchestrator job, but use cheaper, faster models for the simpler tasks. You can also cache results, so if two users ask for the same thing, you don't have to do the work twice. And you can create a fast path for simple requests that don't actually need the whole team.
It's all about being smart and efficient.
Okay, and this is the question that probably keeps the engineers on these projects up at night. You've got all these different AI agents talking to each other. What happens when one of them just fails? Or when an API is down? Or what if two agents come back with conflicting answers?
The answer is to plan for failure from the very beginning. There's a concept for this called graceful degradation. Instead of the whole system just crashing and burning, it does its best to give you a useful result anyway. So if the flight search tool is down, maybe it uses data from a few hours ago and just adds a little warning. And this one is so important. If the system can't be 100% sure a restaurant is safe for that peanut allergy, it doesn't guess. It leaves it out. Safety has to come before completeness.
And that whole safety piece leads us to a really crucial point. These systems are getting incredibly powerful, but we're not just going to hand over the keys and walk away. Keeping a human in the loop is a fundamental part of the design. A great way to think about this is with something called a trust ladder. You don't just flip a switch and go to full automation. You have to earn trust and climb the ladder, rung by rung. Right now, in 2026, most products are aiming for level 3 or 4. That means the AI is doing the heavy lifting, but it either needs a human to click approve on key decisions, or it runs on its own but flags anything weird for a human to review. It's all about finding that sweet spot between powerful automation and that irreplaceable human judgment. So, let's put all the pieces together. Now that we understand the architecture, where do things stand today? Let's take a look at the maturity of these systems and see what the road ahead really looks like. This maturity model gives a fantastic snapshot of the entire industry. Level 1 is basically all of us just using ChatGPT. Right now, most companies building real AI products are at level 2 or 3. They're either using a single agent or a simple pipeline. The next great frontier, the big leap everyone is trying to make, is to level 4. That's building those truly robust, orchestrated systems that can handle real-world messiness, with all the cost management and failure-proofing we've been talking about.
And that brings us to what might be the most important takeaway of all. It is so tempting to build these wild, complex, multi-agent systems because they're cool. But the best design is always the simplest one that actually solves the user's problem. Don't build a team of 5 agents when a simple 2-agent pipeline will do the trick. Every bit of complexity you add has a cost, in money, in time, in risk. You have to make sure it's absolutely justified. So, I'll leave you with this final thought to chew on. As we shift from just using a single AI tool to actually managing these teams of AI agents, our own roles have to change too. We're becoming managers of digital specialists. So the question for all of us is, what new skills do we need to learn to be good at orchestrating, debugging, and leading these incredibly capable new AI teams?